Yeah.
Good day, everyone. We are the Group 1, and the corresponding member of the group is Engine Cadet ABEJERO, Engine Cadet ADALID, Engine Cadet ALIPE, Engine Cadet BAGUIO, Engine Cadet Barbadillo, Engine Cadet BULILAN, Engine Cadet CABUNILAS, Engine Cadet BAQUILTA, Engine Cadet BUTANTAN, and Engine Cadet ANDUYAN. So learning outcomes. At the end of this session, the students should be able to identify engine performances essential for monitoring and recording during the operations of marine diesel engines such as engine load, exhaust system, cooling water system temperatures, and engine performance test. So the first topic that we will discuss is engine load.
Good day, everyone. So I am Engine Cadet Baguio. So for today's topic, so engine load. What is engine load? So the engine load is the torque output of the internal combustion engine, and the internal combustion engine is approximately a constant torque motor. So meaning it can produce the same maximum torque at any RPM. So the fact that it happens at an RPM or another dictates how much power it produces. Next slide, please. So, what is load factor? So, load factor, the engine load factor is defined as the actual power output of the engine relative to its maximum continuous rating, or the MCR. So, the load factor is normally specified in percent. So, for example, an engine working at 50% of its maximum load has a load factor equal to 50%. So we have a diagram. So the diagram shows that under load conditions, the SFC of the engine will increase. So it means engine efficiency will reduce. Although the load of the main engine is primarily dictated by shift speed, the load of the auxiliary engine depends on the shipboard electrical loads that are a function of number of machinery, and equipment being used at each point in time plus the number of engine used to satisfy the requirements. So in the diagram, it argued that the engine load should be managed where possible so that the engine fuel consumption is minimized. So it will effectively mean operating the engine at 70 to 90% load range as discussed above is possible.
So I'm Engine Cadet Abero and I'm going to continue with the topic. So for the load management for main engine, it is a direct drive or gear drive configurations mechanically linked to the propeller. There is not much that can be done as far as load management is concerned, as normally ships have one main engine and load management normally applies to cases with more than one engine. In the figure 5.1, typically, it increases in power fuel required to maintain vessel speed of a fast, fine ship versus increasing hull roughness, according to International Paint 2004. So therefore, in engine, a non-optimal operation may be allowed due to slow steaming because of slow steaming greater benefits. However, in such conditions, and if slow steaming is going to continue for the long term, engine performance characteristics are recommended via changes to turbochargers, injection systems, and other engine settings. Engine adjustment for slow steaming optimized operation. So, no matter what load the main engine is operating under, it is most recommended that the main engine load be kept at a reasonably steady level under regular operation. It is achieved by keeping the engine speed or RPM in constant. Frequent changes to the shaft RPM, thus engine load, are not efficient and must be avoided. Next slide, please. For the method of analysis, first is to evaluate the prevailing practices on the use of auxiliary engines. The following areas are needed to be investigated. The load factor of various ships DGs needs to be established by a collection and analysis of data. This measurement is quite straightforward as the DG's power output is normally measured and presented in the engine room control. Second, alternatively, the engine's utilization factors 11 can be estimated. It can easily be estimated from the records of engine run hours that are available every month. From utilization factors for all of the engines, it can be established the period that 1 DJ, 2 DJ, or more DJs have been simultaneously operated. Third, this next step is to evaluate if the utilization of engines are excessive. It will require the evaluation of ship operation profile versus the number of days required for operational or safety purposes. Benchmarks will need to be developed for this purpose. Lastly, final phase is to identify methods by which the runs hours of the engines could be reduced. Thus, you will save fuel. For the method of improvements, there are two ways of improving engine load factors and reducing engine utilization factors. First is to avoid use of multi-engine parallel operation when not needed. To achieve this, careful planning of shipboard activities that require electric power and its implementation is a need. Also, there is a need to keep several operating engines to a minimum as per requirements and avoid the deliberate operation of multi-engine when not needed. And that's all.
So hello everyone. I am Engine Cadet Christian Dev CABUNILAS. Then I will be the one to discuss about the exhaust system. So on ships, the work done by marine engines to keep the plant running for propelling a ship requires burning of fuel. The energy converted inside the cylinder of the engine is not 100% efficient. Conversion is part of it is lost in the form of exhaust gases. Then the modern exhaust gas system of marine engine is designed in such way that unused gases coming out of the cylinders are further directed to turbocharger, an exhaust gas boiler to recover most of the waste energy from the same. So modern exhaust system. So next. So for the components for the exhaust gas system of engine, to utilize the maximum energy from the waste gases, the exhaust gas system of marine engine is provided with the following components. So the first one is the exhaust gas pipes. Second is exhaust gas boiler. Third is silencer. Fourth is spark arrestor. And lastly is the expansion joint. Next, please. So for the first is exhaust gas piping system for a marine engine. Um, it conveys the gas from the outlet of the turbo charges to the atmosphere. So ang gamit din natong exhaust gas piping guys kay siya ang mo transfer sa atong gas nga adto sa turbocharger. Then for designing the exhaust piping system, following important parameters must be observed. So ang atong i-monitor niya kay dapat first is the exhaust gas flow rate, then maximum back force from exhaust piping on turbochargers, and exhaust gas temperature at turbocharger outlet, maximum pressure drop within the exhaust gas system, so maximum noise level at gas oil outlet to atmosphere, sufficient axial and lateral elongation ability of expansion joints, then utilization of the heat energy of the exhaust gas. So mo na atong i-observe dyan. sa exhaust gas. Then exhaust gas boiler. So it is considered to be one of the most efficient waste heat recovery system designed for a ship. So kanilang itong exhaust gas boiler guys kay mo siya ang mo to recover sa atong system kung sobra na yang kainit. Then when the ship's propulsion plant is running at its rated load, the auxiliary boiler can be switched off as the EGB or exhaust gas boiler can generate the required steam for various ship system. Then the exhaust gas passes an exhaust gas boiler which is usually placed near the engine top or in the funnel. So sa makita niyo sa picture no nga, ang exhaust gas boiler na siya sa top. Then next is the silencer. It is used to reduce the noises level in the exhaust gas manifold and they are generally placed after the EGB. So, sabatable rin siya guys. Kay, sa pangalan pa lang daan, silencer. So, silence. Siya ang mo minimize sa kasaba sa atong kuan. Sa saba sa or noise sa atong kuan system. Then, the conventional silencer consists of obstructive and reactive chambers. They are constructed for a gas velocity of 35 meter per second and the reactive chamber is only effective at one frequency. Next, please. So, spark arrestor. The low load operation of marine engine tends to produce partially borne carbon deposits and suit with the exhaust gas piping system of engine. Then, as the exhaust gases produced after combustion are rich with oxygen, these partially borne carbon particles are discharged from the exhaust funnel as highly dangerous spark. So, spark arrestor can be fitted in the exhaust piping system to prevent sparks from the exhaust gas being spread over the house. So, ang gamit sa itong spark arrestor, no, kay ang atong kuan exhaust gas kay namo kuan siya, namo produce siya og kuan ba kanang born carbon. So, para dili siya mo kuan, para di siya mo spread ngadto sa atong deck house, mo ni mo gamit ang spark arrestor. So, it is placed at the end of the exhaust gas system of the engine. So, next please. So for lastly is the expansion joints. So bellows and expansion joints are used. They are designed accurately to make sure that they are able to withstand the stresses and avoid cracks brought about by the continuous change in the temperature of the system. So ang gamit sa itong expansion joints kay sila na ang uh, sila ang mo kwan mo pugong sa atong kwan kang mo crack sa atong system or na-leak. As per Boyle's law, when tubing is subjected to high temperature fluids, pressure also builds up. Expansion joints are needed to bear the extra force that accumulates. Then expansion joints are used in tubing and piping system and bellows are generally used to connect exhaust gas pipes to the funnel. So, kanang sa picture no, mga nang expansion joints. So that's all guys. Thank you.
Madungog ra.
Oh, dumog na.
Okay, thank you. So I'm Engine Cadet MARL BAQUILTA. So I am going to report about the cooling water system temperatures. So the machinery system fitted on board ships are designed to work with maximum efficiency and run for long hours. The most common and maximum energy loss from machinery is in the form of heat energy. This loss of heat energy has to be reduced or carried away by a cooling media, such as a central cooling water system, to avoid malfunctioning or breakdown of the machinery. Next slide, please. So there are two cooling system used on board for the cooling purpose. So number one, seawater cooling system. Seawater is directly used in the machinery system such as cooling media for heat exchangers. Number two, fresh water or central cooling system. Fresh water is used in a closed circuit to cool down the engine room machinery. The fresh water returning from the heat exchanger after cooling the machinery is further cooled by seawater in a seawater cooler. Next slide. Next slide. The double. So the function of a system is to remove heat from process or equipment. Heat removed from one medium is transferred to another medium or process fluid. So this picture in the left side show the diagram on how the medium is transferred to another medium or process fluid. Next slide. So types of system. Water heated in the heat exchange process can be handled in one of two ways. The water can be discharged at the increased temperature into a receiving body, one through cooling system, or it can be called an reuse recirculating cooling system. Each of the three types of cooling systems, once through open recirculating and closed recirculating, is described in detail in later chapters. The specific approach to designing an appropriate treatment program for each system is also contained in those chapters. Next slide. So heat transfer economics. In a heat transfer system, Heat, ex- heat is exchanged as two fluids or unequal temperature approach equilibrium. A higher temperature differential result in a more rapid heat transfer. Next slide. So what is engine performance test? So calculation of ignition timing under various speeds and loads. That test is carried out with a variety of ignition advanced position. In order to establish engine performance levels under various loads, the test is carried out with a variety of ignition advanced position. So engine performance parameters are power, torque, and specific fuel consumption. Next slide. Um, 8 ways to monitor and measure marine engine performance. On ship, marine engines serve two purposes: propelling the ship and generating electricity to assist in powering the ship's propulsion system. The performance of any ship's machinery is closely connected to its efficiency. To get the most out of marine engines, it's critical to keep track to their performance and take steps to ensure effective combustion. Not only would this cut pollution from engines, but it will also lower the ship's overall operating costs. Next slide.
So I'm engine
That's all.
cadet Barbadillo. So number one, measure the peak pressure by mechanical peak pressure gauge. This method is commonly used in four-stroke generator engines, where each cylinder has a peak pressure gauge and the pressure created during combustion is recorded. When the unit is not firing, the compression pressure of the cylinder is likewise measured with the same gauge. 2. Indicator card measurement. Another mechanical approach for measuring engine cylinder performance is used to an indicator drum and plot a graph on cards. For this purpose, two sets of cards are used, power cards and draw cards. So we can calculate the compressor pressure, peak pressure, and engine power using these two diagrams, which is the power cards and the draw cards. The 3. Digital pressure monitoring by DPI. The digital pressure indicator is an electrical method for monitoring the engine's power and performance. The fluctuation in cylinder performance can be plotted and evaluated in graphical form with the use of DPI, and corrective action can be done. 4. Intelligent combustion monitoring. ICM, which measures real-time cylinder pressure in all engine cylinders, continuously monitors the latest generation engines. This package includes a variety of data processing tools for analyzing performance and diagnosing engine problems, which is extensive blow-by exhaust valve operation, fuel injections, and etc. 5. Monitoring of engine control parameters, fuel injection timing, exhaust valve timing, variable turbocharger, vane opening angles, lambda control, and other engine control parameters are monitored and any variation are set to produce the most efficient combustions possible.
I'm Engine Cadet Bulilan as continuation. 6 is the engine parameters. The engine parameters are the most reliable source for identifying any faults or differences in engine performance. To accomplish effective combustion, variation in temperature, pressure, and power reduced by each cylinder must be closely monitored and adjusted as needed. 7 is logbook monitoring. This is the simplest approach for checking engine performance, but if it is frequently overlooked, on board, the logbook record for engine room machinery is retained for years. 8 is engine emission. After the combustion, the marine engine produces waste smoke, which is exhaust smoke. Engineers must know which exhaust trunk discharge is devoted to which engine, and the color and nature of the exhaust should be regular checked. Diesel engine monitoring system types. The diesel engine's performance can be measured easily and quickly with the use of monitoring equipment. There are two sorts of monitoring system available with the new technology. The performance of the diesel engine is continuously checked in the first system, which is referred to as online monitoring. In the second approach, the engineer must manually mount the instrument on the cylinder head, attach the wire to the RPM sensor, and manually take readings before transferring them to the computer. On ships, the primary engine typically has an online diesel performance system, whereas diesel generators typically have a manual system. Advantages of diesel performance system. First is efficient and reliable operation of the engine. Second is it helps in saving fuel and optimizing SFOC or specific fuel oil consumption. Third is it helps in predicting the necessary repairs and preventing engine failure. Fourth is it helps in reducing spare parts cost and increasing time between overhauls. And I think that could be all for our report. Thank you.